Hello learner, welcome to Manifested Online Classes. My name is James Kenyani. We are going to proceed with our topic on further logarithms, and in today's lesson we are going to look at laws of logarithms. Laws of logarithms. So the lesson is laws of logarithms. The main objective of this lesson is to enable the learner to know these laws and to apply them in computations. So the objective is to enable the learner to know the laws of logarithms and use them in computations. So learner, here, there are three main laws of logarithms, as I'll write them down. Logarithm to the base x. Logarithm to the base x a b is equal to logarithm to the base x a plus logarithm to the base x b. That is the first law. The logarithm to the base x a multiplied by b. I think you get this from what you did in book 2. When you are multiplying 6 times 4. When you use the logarithms, you got the logarithm of 6 and got the logarithm of 4 and added. Then you got the anti-log to get the answer. That is what's basically coming here. So long as they are of the same base. So long as they are of the same base. You can relate it to what you did in book 2. But in book 2, most of the time you are using the base 10. So note that in most questions where the base will not be given, you'll assume that it is to the base 10. Where the base is not given, you always assume it is to the base 10. That is the first law. I've just given. The second one, I think you've experienced it. Logarithm to the base x, a divided by b is equal to the logarithm to the base x of a subtract logarithm to the base x b. I think you got that experience in book 2, only that you are using the base 10. If you had a number like 565 divided by 211, you got the logarithm of 565 and got the logarithm of 265, and then you subtracted because you are using the same base 10. That culminates to that law, although we shall know where it came from. Lastly, the third law is where you are given logarithm to the base x, logarithm to the base x a raised to n, a raised to n is the same as having n, isn't it? N will come this side. You'll have n logarithm to the base x a. I can give a good example. Like if you say 6 raised to 9. 6 raised to 9. It is 6 times 6 times 6, 9 times. But in book 2, if you would have used logarithms, you would have got the logarithm of 6. Then you would have added it 9 times, then get the anti-log. It is similar to this. You are getting the logarithm of a, and n times to get the answer. But where are these derived? The above laws are derived from the law of indices. The above laws are derived from the laws of indices, sometimes called powers, the laws of indices. Relating to the first one, we have the first one, x raised to m times x raised to n is equal to x raised to power m plus n. We shall find how that comes in. If we have x raised to m, like 2 raised to 3 times 2 raised to 7. 2 raised to 3 times 2 raised to 7. It is the same as 2 raised to 3 plus 7. It will give 2 raised to 10. That is the first derivation. In the second one, that comes out with that law. If you have x raised to m, x raised to m divided by x raised to n, it is the same as having x raised to m minus n. Think we've experienced that. Huh? Is, for example, when you have 2 raised to 9 divided by 2 raised to 4. It will be the same as 2 raised to 9 subtract 4. The third one, law is when you have the third one is when you have x m, we have xm into brackets n is the same as having x m multiplied by n. It is the same as just having x m multiplied by n. So let's go to the first one. We go to the first one. In one, proving one, we want to prove from the laws of indices that this is correct. Proving that we want to prove that log base x a b is equals to log base x a plus log base x b. So what you simply do, learner, you let a is equals to x raised to m and b is equals to log is equals to x raised to n. That is what we first of all do. So where you have that, you'll substitute. So you'll come and say, now from that you'll get, I've said x raised to m is a. X raised to m is a. Therefore, AB, log to the base x, log to the base x a is equal to m. From how you are changing the indices. log to the base, log a to the base x. This is always the base. That is the base will give you m. Consequently, the second one, log of b to the base x is equal to n. You remember in the last lesson what we did. So when you have these, you say log to the base x of a is m. Log to the base x, log of b to the base x is equal to n. So from there, now AB is equal to x raised to m, x raised to m times x raised to n. X raised to m and x, because you have substituted this here, you find how it comes there. AB, isn't it? When you have multiplication in logarithms, it is addition. Now x raised to m is equals to x. Now AB will be equal to x raised to m times x raised to n. Therefore, when I'm here, the log to the base x, AB to the base x AB will be equal to m plus n. M plus n, which is equal to log, you'll also come here, log base xa plus log base xb. So when you come to the second, it will just be the same, proving, you'll want to prove log base x a over b is equal to log base x a subtract log base x b. So you'll just use the same division. It will only be a division. It will only be a division. So you'll use the same here. Using the same here, AB, instead of now multiplying, you'll use that relationship, and then when you reach now, you'll say now A, when you reach there, now A over B will be equal to x raised to m over x raised to n. X raised to m over x raised to n. So when you come here, when you have division in logarithms, it is you subtract. You'll subtract. So you'll come and say log base x a over b, a over b, a over b. When you have division, it will be subtraction, will be equal to m subtract n. M subtract m. M subtract n, which will be log to the base x of a subtract log to the base x of b. So you realize when you have division, there is a subtraction. When you have multiplication, there is addition. Whenever you have multiplication, there is addition. And lastly, the last one, where we have proving, we have to proving log base x log base x a raised to n is equal to n log base x a. So I gave an earlier example where this could be 2 raised to 6. So it will become 6 log base x a. But now let's prove here. Let x raised to n m is equal to a. Let x raised to n be equal to n. So when we are proving, so the third one was here. This index is the one that we are supposed to use. So we have m inside. So I've taken this one to be a. So let x raised to m be a. Therefore, an, I'll now take the whole of these. An will be equal to x mn, and it's the same as x nm. So from there, you can get the logarithm. Logarithm to the base x a raised to n will be equal to mn or nm. Just what we are getting there. So from there, we can come and say log base x an will be equal to n log base x a. So from here, there is something we didn't get, we skipped. You are supposed now to express this as log of a to the base x is equal to m. Log to the base x of a is equal to m. So that's why it comes here. Since there is a multiplication, we know this one is m. So it will be multiplied by n. That's why the n comes there. So that is how we prove the 3 laws of logarithms. So let's look at examples. After proving. We have examples. Write as a sum or a difference of logarithms. So Lana, I said, if you are not given any base, you'll assume that those numbers are written to the base 10. They are written to the base 10. So we have log AB. So writing to as a sum or a difference. If we have multiplication, AB, the logarithms will take the addition. It will become log A plus log B. In this case, Lana, they have not given a base. And I said where they have not given any base, assume that the base is 10. So we have log A, B, C. It will become log A plus log B plus log C. You see, it's quite easy. When we have multiplication, we have addition of the logarithms. When we have log A over B, it will become log A subtract log B ln. That is how the laws start working. When we have log A over BC ln, it simply becomes log A subtract into brackets, because these ones are combined, subtract log B plus log C. So it's as simple as that. When we have multiplication, when we come to the logarithms, we add. I think that you got that in book 2. Like 6 times 5. You get the logarithm of 5, get the logarithm of 6, and you add and then get the antilog. We have other examples expressed in terms of, so expressed in terms of log A, log B, and log C. We have A log A squared over B cubed. So this will become, it simply becomes log A squared subtract log B cubed. But there is something you've learned here. You can apply it. This power can come there. So it will become, it is the same as having 2 log A subtract 3 log B. As simple as that. You apply that one. Log base XA, A raised to N is the same as N log A to the base X. So with that, work out this. Work out this. So before I go to that, they can tell you to give you this, and they tell you write that. So if they have given you these addition in logarithms, when you come to putting together, it will be multiplication. If it is a subtraction, you see it becomes a division. So it can be vice versa. So before I go very far, if you have these, 2 log, if we have 2 log 4, 2 log 4 is the same as log 4 squared. You take 2 the other side, it will become log 4 squared. So this will be the same as log 16 raised to a half. Number 3. So learner, for the assignment, work out that. You write as a product of the logarithms or a division. So here you have a product. Here you have a division. So write as a product of the logarithms or a division. Or instead of writing that, instead of this, write, let me just express as a single term. Like if we have log 3 plus log 5, it will be log 3 times 5. So this becomes log 15. I have written as a single term. So express as a single term, log 2 plus log 5. 2 log 5 plus a half log 16. Log 12 plus log 25 minus log 3. 2 log P plus log Q. Log 12.5 plus thrice log 2, and 6, 3 log x plus a half log y. So work out through that before we meet in the next lesson. So thank you and bye-bye.